Hey guys, so today we're going to talk about transformations of the mother functions. So in geometry, we learned about the translation, reflection, rotation, dilation, the stretch. Talked about other ones, uh, shearing. But let's see which of those we can do with these mother functions. So a translation, that's just sliding it. So yeah, we can obviously do that. That's perfectly fine. Nothing weird about that. And we call the translation a shift. Could be a vertical, up and down on the Y, or horizontal, or both. Forgive me if I misspell something. Then we've got a reflection. Okay, that one we call a reflection. Yeah, I know it's complicated, right? So we can do that. I can mirror it in the x-axis. See, I can, where'd it go? Oh, it's frozen. Hang on. There it goes. See, I can reflect it that way. Oops, it didn't group. So I can reflect it over the x-axis or a horizontal line. I can reflect it over a diagonal line. I can reflect it over a vertical line. But since this thing is a absolute value mother function, I'm really not going to be able to tell the difference if I reflect it over a vertical line. Thinking. See. So we might be able to tell a little bit since I suck at drawing. Notice that this arrow moved over here. So this line segment here is this one here. It reflected over the y axis. So reflections, we call those reflections. Could be over the y-axis or any vertical line. But for our case, we're going to do just the y-axis. Could be the x-axis. We could also do a diagonal, but we're not gonna. Rotations, let's think about this. Okay, if I grab this mother function right here, I start turning it, what's wrong with that? That's not a function. So rotations are out. We cannot rotate. Rotations are a no-no. Dilations, yeah, sure, I can grab this thing and I can make it bigger or smaller. I can dilate it. But more interestingly, I can stretch it. I can stretch it on the vertical and the horizontal at different scale factors. So we actually don't do dilations, we do stretches if it gets larger, and we call them compressions if they get bigger. So again, dilations are out. We can do it, but even if we did do it, we'd call it a stretch. So come on. Stretch X or Y. So you can stretch it horizontally, you can stretch it vertically, and it gets larger, respectively on the X or Y axis. Compression, or compress, is what we call it when it gets smaller. So if I were to take this mother function right here and just grab this and squish it, that would be a horizontal compression. Okay, that's it. So shifts, we're going to start with those. Reflections and stretches, that's all we got. That's how we're going to transform these mother functions. So let's start with this one. So I've got my basic mother function graphed right here. Well, what is this? I can look by the power. I can look at the shape of this thing. That's a freaking parabola. That's a squared. That's a quadratic mother function right here. You need to be able to look and see what they are. Now here in red, I'm going to transform it. Let's see what happens if I subtract 2 from the x values. So you can use a calculator and just plug it in. I'm just going to do it in my head. That's going to be -4 squared is 16. That's a little off the graph. -3 squared is 9. -2 squared is 4. -1 squared is 1. 2 squared is 0. Let me add a few of these here. 3 minus 1, that's 1. 4 minus 2, that's 4. Okay, so looking at my Cartesian plane here that I got, it only goes to 6, so these, I can't do these two. I'm going with 0, 4, 1, 1, etc. So plot them. 0, 4, 1, 1, 2, 0, 3, 1, 4, 4. Huh. Now remember, whenever you're drawing these things, you got to watch your butt. For a quadratic, it better have a nice, round, smooth bottom. The rest of the graph, I'm not so worried about. It can be pretty crappy looking. It's fine. But you got to watch that bottom. Because I got to make sure you know that this is a quadratic and not an absolute value. So examine this. How did I get from the blue to the red? What did it do? Well, everything just went right 2 units. Look at that. I took this point right here and moved it right 1, 2 spots. I took this point right here, the blue one, and moved it 1, 2 spots to the right. 1, 2. Everything shifted 2 places to the right. So let's write that down. That's what happened here. Okay. Let's look at some more examples. All right, now this one, you better be able to tell me that's the absolute value mother function. Okay. Excuse me. -2 plus 1 is -1. Absolute value, that is 1, 0, 1, 2, 3. Just plug them in there in my head. Use a calculator if you need to. It's easy. -2, 1. -1, 0. 0, 1. 1, 2. 2, 3. I think you can see the picture here. So for these absolute value mother functions, I'm definitely going to use my straight line drawing tool. I'm not going to use that for my quadratics because it's not a straight freaking line. Absolute value though, that's the one mother function you can use the straight line tool on. Well, that and linear obviously, but we've already done that. We've probably done many of those. Linear aren't very interesting for transformations, so you can pretty much not worry about those right now. We already did that. Passed. What happened here? Well, to go from the blue to the red, I just went to the left one time. Okay. Left 1 unit. Cool. Keep going. All right. Hey. Here we go. We've got a cubic mother function. Look at that. And again, I'm just going to plug in these numbers, and they could go off the graph, so we'll see what happens. I'm going to have to put some different numbers here. -8 plus 1 is -7. Okay, it'll work. 0, 1, 2, yeah, 8, 9. Obviously, I can't do this one, so I can do these 3. In my head, it wasn't looking right at first, but it's perfectly fine. -1, 0, 0, 1, 1, 2. Okay. Can't do 2 9s stuff here. When you're graphing these, I suggest starting right here at this midpoint. Curve it up. Then go it in, curve it down. And it doesn't need to be perfect. Just do the best you can. If you draw a straight freaking line or something crappy like that, though, you're not getting your points. Try. This is going to be on paper, by the way, if you're an in-class person. At homies, draw better. Just get a touch screen or something, I don't know. Just pay attention to what you're doing. Make sure it looks right. So what happened here? I'm sure you already noticed it went up 1. And that is, again, a shift. So everything here went up 1 unit. Keep going, keep going. Maybe, if it doesn't freeze. Here we go. Another absolute value mother function because they're easy to work with and draw. And I'm lazy. All right. Plug in these numbers into here. You get 0, -1, -2. Oh, I'm going to need to go some more negatives, aren't I? No, I'm not. Wait. Let me make sure I'm doing this right. 0. Yeah, okay, I'm good. -1. 0. Huh. Interesting. Let's plot them and see what happens. -2, 0. -1, -1. 0, -2. 1, -1. 2, 0. Huh, look at that. What happened here? I hear you hollering out. That's exactly right. It went down 2 units. And that's all the different kinds of shifts we got. So here's a summary of it, I think. Nope. Okay, make sure you know what these things are just by looking at them and be able to look at their equations and tell what they are. So this is a cube root mother function. Cube root, like that. Absolute value mother function. This is a square root mother function. This is the reciprocal mother function. I'm not going to do too much with him right now. And he's going to have his own week, pretty much. So here's a summary of shifts. Horizontal shift. If you notice, it's the opposite of what you think it should be. So if it's a minus A, you're going to go right. If it's a plus A, you're going to go to the left. So this is function notation. You should be familiar with this. If you're not, here's a more physical example. What's going to happen in here? It's going to go right 3 units. And it's going to go up 2 units. Okay. So in here, inside of the function, what is a function? It's the square function. It's being squared. So the -3 is being squared. It's on the x-axis. It's horizontal. It's with the x. It's on the horizontal. That's for stretches, compressions, reflections too. We'll get to reflections. Yeah, it's with the x. So for, x is just always backwards. Just think of it that way. It's a -3. You're going to go to the right 3. It's a +3 up in here. You're going to go to the left 3. Now on the outside, that's not inside of the function. That's outside of the function. It's shifting the entire graph up or down. In this case, it's going up. So that's our shifts. So let's try some. Let's get in the habit of writing down what we're doing. First, what kind of mother function is it? Absolute value. I'll abbreviate. What kind of shifts do I have? Left 2, up 1. So start with those basic points. No, not that picture. That picture. So it's the absolute value mother function. Remember, these highlighted points need to be up here. Like, just memorize it. You got to know what these things look like. You got to know what these points are. You need to know the domain of the range. It's just a bunch of memorizing for this stuff. It's not too terrible, though. There's only a few steps you need to know. So absolute value. I'm going to do the basic mother function in blue. It's got the ordered pair 0, 0, 1, 1, -1, 1. And I'm not going to actually draw the graph until I've transformed all of my points. So I'm just going to plot the points, transform them, and then I'm going to draw my final answer. Otherwise, it'll get very confusing. One good thing about the computer is you can easily color code it, and I'd highly advise that. So here's what I got to do. Go left 2, up 1. 1, 2, yes. 1, 2, 1. Oh, there. 1, 2, 1. 1, 2, 1. There it is. There's my transformation. That's the daughter function. This blue function birthed these points. That's what happened. By a miracle of math. There we go. What kind of mother function we got going on here? Quadratic. What kind of shifts we got? Right, 1, down 3. Okay, quadratic mother function, same basic points as the absolute value mother function. 0, 0, 1, 1, negative 1, 1. So remember, the difference is how we draw these. I use my straight line drawing tool for the absolute value. Cannot do that for the quadratic. Let me shift these points. Right 1, down 3, right 1, down 3. Okay, okay. So for these, remember, most important, rounded bottom. And then something like that. Rounded bottom, and something like that. Beautiful. Terrible, but perfect. So, just make sure it looks parabola-ish. You're good to go. Also, make sure I can see your points. So if it helps, you can draw your graph in different color or put your points in different color or something. Whatever you got to do. Make sure I see that you're on these points, because it's very likely that you're going to miss them. Like whenever you're trying to draw it, so just make sure I can tell where your points are supposed to be. Listen, it's okay. All right. Getting bored of this one, huh? Cubic mother function, left 3, down 2. By the way, you can always like pause this before I put the answer and then see if you can get it. Now the cubic mother function has a different set of basic points. The linear, cubic, and cube root. Cube root all have the same basic points. 0, 0, 1, 1, negative 1, negative 1. I'll pop those on here. 0, 0, 1, 1, negative 1, negative 1. So yeah, that could be a straight line. That's the same points as a linear. Could be a cube root if you go nice and short and fat, or it could be a cubic if you draw it like a cube. That's why you must know what these things look like. Transform it. Left 3, down 2. 3, down 2. Left 3, down 2. Left 3, down 2. Then draw it like a cubic. So I like to go kind of like that. And kind of like that. See, that was pretty bad, but it works for me. Good enough. Make sure if you draw a straight line here, or you're just lazy, gotta draw it right. All right, how many of these do we have? A couple. I think you get the picture. I'll write down what's going on here. You do the graph if you want to. If you want to see the graph, you can always just go to Desmos, DESMOS. That's the online graphing tool I told you about. So what kind of mother function is this? Cube root. What kind of shifts do I have? Right 1, up 4. Do it. Done. Same basic points as the cubic. Now this is a square root. I go left 3, down 2. Its basic points are 0, 0, 1, 1, and 4, 2. Again, that's on this sheet right here. Needs to be committed to memory. Okay, now let's talk about going the other way. What if I have the graph and I want you to tell me what happened? So what's your basic mother function here? You better be able to look and tell me it's a quadratic. So then go ahead and plop your basic points on there so you can know what we're referring. Oh, wrong color. Not wrong color, but different color. So these are my basic points. I like, personally, that's just me, to look at my butt. Didn't quite sound right. The butt of my function. So here to there. Or the center point if you're talking about a cubic. I like to look at this point. It just, makes it easier, in my opinion, to see what happened. So how did I get from here to there? Well, I went right 2 units and up 1 unit. Does it work for this point? Right 2 units up 1 unit? It does. So my transformation was right 2 up 1. So let's see, f of x equals, well, it's quadratic, so it's something squared. X, I need to go right 2, so I need to go minus 2. Up 1, so I'm going to stick a plus 1 out there. Boom, done. There it is. Okay. Here we got an absolute value mother function. We went right to it. Hey, it's not interesting. Let's see, do we have different? We don't. Oh well. Absolute value, right 2, up 1. Looks like this, right 2, up 1. Okay. And debating on whether I should break this video up into several. Nah, I'm going for it. Let's just do it. Reflections. So if you multiply your function by a negative, you get a reflection. That's where reflections come from, is the negatives. If it's outside of the function, it's not inside the parentheses with the function or the absolute value bars or whatever kind of function you got. If it's outside of it, you reflect over the x-axis. So you go like from here down or up. It's terrible. It works better if we're in person. So we have something over here, it reflects it over here. That's the negative f of x. That's over the x-axis. If we have negative inside the function, remember, multiplying by x, or the function, it's got to be multiplying, not adding or subtracting. It's subtracting. You'd have something over here reflected over here, or vice versa, whatever. That's a reflection. Now, order of operations applies for these things. We're not there quite yet, but we multiply before we add subtract, right? We reflect before we shift. It's just how it is. So if the negative is with the x, it's over the y. If it's outside, it's over the x. Same thing I said right here. So squared, basic point. And I'm not going to draw the dang thing because, well, I have to draw something later. Negative x squared. That negative is not being squared. I'm going to reflect over the x-axis because it's outside of the function. So this one, you know how to reflect it. I go down one, so I go down one. I go nowhere, so I go nowhere. I go down one, so I go down one. Now we're going to graph this thing. Down, but there we go. And we got a graph. That's a reflection. Let me write that down. Reflect. Quadratic. Reflect over, which one do we do? The x-axis. Notice this one. The negative x squared here. It's with the function, so it's still quadratic. It's inside the function, so it's reflect over y-axis. So you might be thinking something right now, and you're right. You're not thinking well, then just keep watching. Oops. So I'm gonna do something a little different here. So I'm gonna put all my points in different colors. This is my basic mother function right here. How about a nice brown? Okay, I'm actually going to draw this. Swallow, what you doing? What you doing, Swallow? You'll see, you'll see. Don't worry. Here's D, too bad. I'm reflecting over the y-axis, right? So that means this red dot is going to go right here. This brown dot is going to go right one here. It lands on itself. So the red piece lands on the brown piece, and the brown piece lands on the red piece. Okay? So visually, nothing happens. We don't see anything. It looks exactly the same as the original. But, you know, everything on the right half of our parabola reflect over to the left side. Everything on the left side of the parabola reflect over to the right side. Visually, though, no difference. Let's look at this one. Basic mother function. Cubic reflect over y-axis. Popping basic points down there. So now, this is going over the y-axis, 1, 1. This is going over the y-axis, 1, 1. Any point on the line of your reflection doesn't go anywhere. So there we go. Now, we got to draw this thing. It's going to look something like that. Something like that. That's it. Now for the cubic, if you reflect over the x-axis, let's see what happens. So if I were to go up 1, I go up 1. Down 1, I go down 1. So any reflection on the cubic is going to look the same. Odd. Nope, not going to go there. Here we go. Hey. Can't be having answers up on here. It's a square root mother function. Yeah, it's over the y-axis. So this one really matters. You got to really pay attention. Again, different basic points. It's right here. There's your basic points. Look. 0, 0, 1, 1, 4, 2. That's my basic points. I'm going to reflect that over the y-axis. So this one's going 1, 2, 3, 4. 1, 2, 3, 4. 1, 1. Nowhere goes nowhere. Okay. Take more battery than I thought. And just kind of sketch it like this. Try not to make it too straight. Something like that. It's not linear. Don't make it linear. It's curvy. It's much curvier than I have it. I suck at drawing. That's good enough. And that's that. Now here's an interesting one. I'm going to reflect over x and y axis. This is a cubic. It will reflect, and it will reflect again and land right back on top of itself. Now, it's very important. Which one do we reflect over first, the x or the y? Who cares? Doesn't matter. I wrote x first, so I'm gonna do that first. You can do y first, you get the same resulting delta function. Okay, I'm on the axis of reflection. Yeah, so not going anywhere. Down 1, down 1, down 2, down 2. There we go. Now, I've got to reflect these guys over to the other side. Now, some people find it helpful once they do use a point, they cross them out. because you're going to get a lot of points on these things. So if you're using just a pencil, crossing out's kind of helpful. So I'm going to go 1, 1, plop a dot. Of course, if you're doing it on Cami, you could just change your color again. Don't use neon green, it would hurt my eyes. That's gone. I'm gonna go 4, 4, 4. And there we go. This guy's right here, not going anywhere. So now I'm gonna connect these dots. And you can imagine we're gonna do reflections, shifts, stretches all together. So it's gonna be a lot of points sometimes. Yep, I'm gonna try not to that sucks. See if I can draw this thing. Nope. There we go. Almost not terrible. But that's it. Good enough. Again, make sure I can see your dots. Anything, even something crappy like this will work. Reflections and shifts. Reflect, then shift. Simple. We're gonna do like 2 of these. Oh, hey, 1 and 2, cool. Reflect first, then we shift. So let's start by what kind of mother function is this? Quadratic. I'm gonna reflect. And that's outside. You can obviously see me pointing, can't you? That's outside of the function. See, it's not being squared. The negative is not being squared. It's not negative x inside the parentheses. It's outside. It's not with the x. Just going over the x. And then we're going to shift that thing down. No. Up. No. Where is it? It's up in the parentheses. Left. 1. Yeah. Remember, it's opposite sign. +1, you think, right? Basic mother function. Let's go. Quadratic. These are the points. Reflect that thing over the x-axis. Boom, boom. You're going nowhere. Cross them out if you need to. Different color if you want. Shift left 1. Boom, boom, boom. These are gone. Something like that. Something like that. See, I missed the point totally, entirely. It's okay. That's why you need to make sure you mark your points. The end. Next. Square root. Reflect, reflect over. Oh, again, the x-axis. Should have done that one. X is right 2, down 2. Let's do it. Well, no, yeah, no. Boom, boom, and boom. X-axis, let's go. Boom and boom. Right 2, down 2. Not R2D2. But if you see, you could abbreviate that. R2, D2. Ha 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 ha. Anyway, right. Well, let me start here. Let me change the color. Right 2, down 2. So this guy's floating down here in the middle of nowhere. Trying to suck. There it goes. It doesn't suck at all. That's it. That's the graph. Don't go this way. There's nothing this way. It's just nothing there. It's not part of our domain. Domain and range. What's the domain here? 2 to frickin' infinity. What's the range? Negative infinity to frickin' -2. There you go. Moving on. Long video, but it's okay. I don't feel like making separate ones. Stretches and compressions. Let's get it done. This will be the video for like the whole week anyway. If it is with the x, it's horizontal. Many times with the x, it's horizontal, whether it stretches or reflections, whatever. And it's always the opposite of what you freaking think it should be. It's just the opposite. So if we have f of 2x, that's actually compression. It's going to get smaller on the x's. The x's are, it's going to get shrunk by a factor of whatever the heck this is, 2. If it's on the y, it's vertical, and we're going to 2 times the whole function. F of x is going to stretch it vertically. Now, a vertical stretch and a horizontal compression on a grand scale can look the same. So it just depends on what your function looks like. You'll see what I'm talking about. Okay, 2 times x squared. So I'm going to start my basic points. And then I'm going to, well, my bad, quadratic, right? Yeah, look. Then we have a vertical stretch by 2. That's a factor of 2. That means we multiply our y values by 2. And you know what? Remember, there's also those other points down here. Just so you can, where are here, 2, 4, negative 2, 4. I'm going to pop those on here too, just so you can see. No, you won't be able to see that, will you? Nope. Ignore what I just said. Vertical stretch of 2. Yeah, here we go. What is my y value here? It's 1. So I multiply 1 times, let's see, what's that? 2 is 2. So my y value doubles. So my y value here, 0. So 0 times 2 is still 0. 1 times 2 is 2. So this is going to be my new mother function. Notice it's tough. We got to make sure it's rounded here. Sometimes you might have to go over the end of it and do something like that. It's fine. Make sure you have a round butt. It looks like it got squished horizontally, or we pulled it up vertically. That's really what we did. We did a vertical stretch. There's more examples. Any different graph. Hang on. I'm gonna pause this, get a different graph, be right back. All right, so this is a little bit bigger. It's actually just barely big enough. But it is big enough, so let's go for it. Now I am going to pop those extra points. This is, again, a quadratic. I use a lot of quadratics as well. They're easy to work with. It's a vertical compression by 2. Let's go back and look at what's going on here. So 2x is a compression by 2 whenever it's with the x. What would be the stretch, do you think? Half. So you either got a fraction or you got a whole number, an integer. Integer, well, we consider that a whole number because negative's going to go for reflections anyway. So here's an example of a vertical compression. It's not being squared. That would look like this. It's not that, so it's outside of the function. So you do what you think you should do. You compress it by 2. Really? Multiply by the same. Multiply by half. If it's outside the x, just multiply by whatever's there. If it's inside with the x, divide by whatever's there. Easy way to do it. But we need those basic points. 0, 0, 1, 1, 2, 4. I missed that one. And 3, 8. Yeah, that's it. Now I wanted this so you could see what's going to happen. I'm dividing my y values by 2. Okay. So some of my y values divided by 2 won't look so nice, will they? Sometimes they won't. This one, though, that's 8. I can divide 8 by 2. I get 4. 4. I'm just mirror it. You know, it's symmetric. 4 divided by 2 is 2. Okay. 1 divided by 2 is a half. Is there anything? 0 divided by 2. Oh, that's a hard one. 0. So I'm probably going to kind of ignore this one because it's going to be extremely difficult for me to graph this thing as it is. And then try and hit that. It's not going to happen. Wow, it's like the best half of a parabola I've ever drawn. Wow, I didn't do terrible at all there. Hey, it's good for me. Make sure again that I can see your points. All you got to do to stretch your compression is multiply by whatever your factor is. For a vertical one, it is multiply by whatever it is. For horizontal, divide by whatever your factor is. It's just easy as that. So here we have an example of a horizontal stretch. Quadratic. Should have gone with absolute value. Those are easier. Anyway. Horizontal stretch by a factor of 2. So this one I can go with this. It's fine. Right. Okay. Color. Good enough. Now I'll do this one too. 2, 4. We can do 2, 4. And negative 2, 4. I am going to stretch by a factor of 2. I'm going to double my x values. Now I said, what do you mean? You said you could just divide by whatever's up in there. Yes, you can. I'm going to double the 2. I get 4, right? 2 divided by a half gives me 4. So either way you want to look at it. So my x value is 4. My y value is unchanged. I didn't do anything to it. I just doubled my x values. This is 1. It's going to become 2. I double nothing. I still get nothing. -1 times 2 is -2, not +2. Okay, just throw myself for signs. -2 times 2 is -4. Okay, this is, yeah, I suck at drawing. Just go with it. There we go. Beautiful. Most important thing, make sure this is curved and that you kind of triangle through the points. So I think that's that for that. We're going to shove it all together now. First thing you got to do, what kind of mother function you dealing with? Put basic points on there. Then, now 2 and 3 can be swapped. Doesn't matter, whichever you're more comfortable with. I like reflecting first, personally. But you can reflect or you can stretch first. Doesn't matter. I reflect, then I stretch, / compress. And when I'm doing that, I usually do the x's and then the y's, or the y's and the x's. It really doesn't matter. Lastly, though, you got to get your shifts done. So identify what you got, put your basic points. Reflections and stretches, which I already want to do it in, and then lastly, you do your shifts. You got to multiply before you add and subtract. So here we go. What's going on? This is a cubic mother function. It is reflecting across nothing, none. Stretch, we have a vertical stretch of 2. Shifts, we're going to go right 1, up 2. I'm just going to do a couple of these. Geez, I could have my battery. Let's fit it 2 hours. It's a cubic. Put your basic points. Now I'm going to reflect it. Don't need to. Now I'm going to stretch it by a factor of 2 vertically. That means I take all my y values. This is -1, multiplied by 2, I get -2. 0, say 0. 1 becomes 2. These are gone. Again, it's going to get to be a lot of points. So I'm going to cross out my points. I wonder how annoying this screen will be. Then go right 1, up 2. Very annoying. Right 1, up 2. That's better. Right 1, up 2. Oh, hey, look. Right 1, up. Oh, hey, look. 2. You're gone. And then I'm just going to draw the dang thing. Something like this. Something like, pretty much missed there, but that's okay. And there's my cubic mother function. Transformed. Done. Yeah, we'll do these next two. That's it. Quadratic. I have a negative. It's outside of the function, so it's reflecting over the x-axis. I've got a vertical stretch of 2. Did I spell things right? And then I'm shifting left 2, up 3. Okay, let's look at that. Quadratic, so here's my basic points. Now, if I were doing a compression, I'd probably want to put some more points just to make my life easier because I don't want to deal with halves. But I'm not. I'm doing a stretch, so it's fine. And again, you can reflect first or stretch first. Your choice. I do reflections first. Boom, boom, and boom. You're gone. Vertical stretch by 2. -1 becomes -2. 0 stays 0. 1 becomes -1 becomes -2. You're gone. Left 2, up 3. If I can count correctly. Oh, hey, look, this point comes back. And it is a quadratic, so make it looking something like this. Nice round bottom. There we go. Beautiful. Perfect. Moving on. This is a square root. I'm going to reflect over the the x-axis. I'm going to stretch it. Look, 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 and see. It is in here with the x, isn't it? So I'm going to stretch it horizontally. Sure. I'm sorry, I should have done some compressions. Holler at me in my office hours if you need some help with that. Or look back in the video. We did some. Okay, basic points here, 0, 0, 1, 1, 4, 2. Reflection over the x-axis. Horizontal stretch by 2. Okay, I need a bigger graph for that one. Oh. Yeah, I'm kind of lazy to do this, but let's do it anyway. Okay, we're good. Now I can do my horizontal stretch 2. I'm going to start over here. And these are gone. That's 4 times 2 is 8. Let's see where I need this new graph. 1 times 2 is 2. 0 times 2 is 0. Shoot. Still gotta go right one. Whatever. You can imagine. Right one and up 3. 1, 2, 3. So about here-ish. Right one and up 3. Right one and up 3. That's what I get for making my own stuff. Something like that. I'm going to try, no guarantees that everything will be on the graph. I'm trying to make it on the graph. I might have your assignment in tonight, I might not. I'm definitely going to post this video as soon as I compress it a little bit. I believe that's about it. Let's see, what else we got? Identify the mother functions. We'll get there another day, probably after Thanksgiving. You should be able to identify these, determine the graph based on what it looks like, you know. Yeah. If you can identify reflections and shifts and not so much stretches right now, you'll be all right. You should be able to identify stretches and shifts. Not stretches, reflections and shifts. See, I need to go there. Yep, that's all there's to it. All right, guys, that's it for today. See ya.